Hey guys, we are working on our Unit 4 test review today. Tomorrow will be your test, and the test will be very similar to this review. So if you know how to work out these problems on today's review, then you will do just fine on tomorrow's test. You will not be able to use your review on your test though, so make sure that you're studying whatever it is that is difficult for you. Make sure that you come back here to the website this evening and maybe rewatch the video or rewatch the parts that were kind of hard for you so that you know that you're going to ace the test tomorrow. I'm going to work through each of these problems with you, and your paper should look just like mine by the time you're finished. Now, the purpose of having each student working on their own with their own computer and headphones is that now you can pause and you can rewind. You can go back and watch parts that were difficult before you move on. If you feel really confident on one of these problems, you can pause the video, work it out, and then push play to check your work. So whatever it is that you most need for each problem is what you should do. So again, feel free to pause, rewind, do whatever you need to do so that you can be successful. So let's start with number 1. The table shows the relationship between H, the number of hours Michael worked, and W, the amount of wages he earned. So we see that we have his hours worked and we have his wages. And this, if I were going to label this, these would be my X values and these would be my Y values. Which equation represents the relationship in the table? So all we care about is this relationship. And it says that you must write the correct answer in, quote, English for credit. So I'll show you exactly what I mean by that here in just a second. So what we need to figure out first is how much money he's making per hour. Now I don't know if this table goes back to 0, 0, so I need to take it back to 0. So I'm actually going to put an extra box down here. And we're going to be able to figure out if he works 0 hours, how much does he make? Now it would make sense logically that if you don't work any hours, then you wouldn't make any money. But let's just double check that. So we're going to find our change in Y and our change in X. Well, I can see that my change in X is plus 2. And then here it's plus 2. And from 5 to 7, it's plus 2. And over here, I'm going to have to do a little bit of extra math to figure out what my change is. So let's go ahead and do that. Let's see, 2625 minus 875. I have to make sure, since I'm subtracting, that I line up those decimal points. That's 0. I need to borrow. 12 minus 7. 5, and then 25 minus 8, or I could just borrow from this and I could say 1 and 15. 15 minus 8 is 7, and bring down the 1. So that's a change of $17.50. $17.50. Well, let's see if that's consistent. So $43.75 minus $26.25. So I'm trying to find the difference between these two dollar amounts. Let's bring down our decimal point. 0, 5. We're going to borrow. 13 minus 6 is 7. 3 minus 2 is 1. So again, a change of $17.50. So it looks like this is going to be consistent. For every 2 hours that I work, I'm earning $17.50. But I don't see any answer choices that have to do with 2 hours. I just see H, and H means 1 hour. So this would be 1H, or just H. So I'm going to go ahead and divide this. I'm going to see what is $17.50 divided by 2. I want to figure out not how much I make in 2 hours, but how much am I going to make in 1 hour. So go ahead and pause the video, do your division here, and then push play to double check your answer and your work. Please pause now. Okay, so you're checking your work, and I see that I am making $8.75 per hour. So that means, first of all, if I were going to take this table back to 0 hours, that would mean that I'm going to make $0 and 0 hours. So that is a proportional relationship. And all that means is that I'm not going to have any kind of plus something over here in my equation. So none of these answer choices have a plus b or plus a y-intercept. So we don't have anything to get rid of here. So which one of these makes the most sense? He makes $8.75 per hour. Well, this one says that his wages, I'm going to go ahead and write all of these out in English. So wage equals $17.50 per hour. Well, this is a trick answer because they're hoping that we're going to pick this and forget that we have to actually divide it by the 2 hours that we increased here. Remember, when they're giving us a table, they don't have to give us all of the x values. They can just give us whichever ones they want. So if they want to skip around like this, that's fine. So we know it's not that because he does not make $17.50 in 1 hour. He makes $17.50 in 2 hours. This one, wage, W, equals $8.75 per hour. So that H there means per hour. Okay. C, the wage equals 1. This is 1 times H, so this is hours divided by $8.75. That doesn't make any sense because it's per. Per means multiply. And D, the wage, is $8.75 divided by the number of hours. And that certainly doesn't make sense because then if I work 1 hour, I'll make $8.75, but if I work 2 hours, I'm only going to make half of that, and that would go against everything we know about working. So the answer that I like is that the wage equals $8.75 per hour. And when we say that you must write it out in English, we just mean English instead of math, instead of numbers. If you still have questions over this, please put a star next to it so that when you're finished with the review, you can go and ask your teacher and you can have a little mini lesson over this one. All right, let's look at number 2. Karen lost 1.77 kilograms after a week of exercise. If 1 kilogram is approximately 2.2 pounds, about how many pounds did Karen lose? Round to the nearest hundredth. Okay, we've been doing this a lot lately. These are just our measurement conversions. And so they have already given us 1 kilogram is approximately 2.2 pounds. So you could have this on your math chart if you wrote it in, or it will be given to you in problems. You do not have to memorize this. So I'm going to start, remember our first step is to name our ratio. So I'm going to do kilograms over pounds. And just to kind of help me make sure that I have the right answer, I'm going to circle what I'm looking for. And it says, how many pounds? So I'm solving for pounds. So once I've named my ratio, then I get to set up a proportion. We're going to start with line equals line. And we start with what we know. This is either from the math chart Or if they give us the conversion in the problem, we can just use that. So 1 kilogram is 2.2 pounds. I already set up kilograms on top, so I'm going to put 1 kilogram and 2.2 pounds. Make sure that you're following what you did over here. We want to keep kilograms on top. Now, I know that I have 1.77 kilograms, so that's going to go on top here. And I'm looking for pounds, and of course I already know that that's going to go on bottom. X needs to be on bottom, so we are all set up here. So now all we need to do is cross multiply. 1 times x is 1x, or I can just say x, and 2.2 times 1.77, we need to multiply that out to the side. So I need to set this up just like this. Remember, we're multiplying, so decimal points do not need to be lined up. No adding extra zeros or anything. So I'm going to ask you to solve this one on your own. Go ahead and finish out this answer, and then you'll be able to push play and double check your work. So please pause the video now. Okay, so when I did this, I got 3 and 894 thousandths. Did you remember to count your digits after the decimal point? I have 3 digits after the decimal in my problem, so I have 3 digits after the decimal in my product. So I'm ending up with 3 and 894 thousandths. However, there's one thing that we still have left to do, and that is to round to the nearest hundredth. And we are very familiar with this because this is the same as number 1 on Mountain Math. We're rounding to the nearest hundredth. So first I need to identify my hundredths place. This is tenths, this is hundredths. So this is going to be the last digit in my answer. I need to look to its neighbor. The 4 tells me to round down. So my answer is 3 and 89 what? Okay, we need to label our answer. So 3 and 89 hundredths of a pound. Again, if this one is causing you some trouble, if you're still not really sure about this, go ahead and pause the video and put a star next to number 2. And then be sure that when you're finished with the review that you go and ask your teacher about this. And make sure that you have all of this work on your paper so that we can identify exactly where you're struggling and get you some help. Okay, number 3. Janet won the 400-yard dash. If her average speed was 8 feet per second, what was her time for the dash? So, let's go ahead and look at what we have here. First of all, we know that we're going to be using this formula. Distance equals, I'm going to do this in colors here so that we can see it better, rate times time. That's our formula. Distance equals rate times time. Now, this is going to be a multi-step question here, so we need to start looking at what we may need to change. Okay, we know it's a 400-yard dash. We also know that her average speed, okay, so this is our distance, 400 yards. We also know that her speed, or her rate, was 8 feet per second. Okay, well, we have a problem here. 400 yards, but our rate is in feet. So we can't be doing that. We have to convert everything into the same units. So my preference is always to go ahead and go to those smaller units. I'd rather change yards into feet. And we know from our formula chart that 1 yard equals 3 feet. So we're actually going to have 2 parts to this problem. Let's give ourselves just a little bit of space over here on the left for our distance formula. That won't take too much space. But over here, we're going to do another measurement conversion problem. So I want to turn, basically, I'm asking myself, 400 yards equals how many feet? And that's what we're solving for. So just like up here, we named our ratio, kilograms over pounds. Here we're going to name our ratio, yards over feet. Again, you could do feet over yards, but this way is just the order it's given in the problem. And then we're going to set up our proportion. Line equals line. Let's start with what we know. We know that 1 yard equals 3 feet. So 1 yard, 3 feet. And I know that I'm solving for feet. So X is going to go on the bottom over here. What are our yards? We don't know our yards. Oh wait, yes we do. 400 yards. So we're taking 1 yard equals 3 feet. So 400 yards equals how many feet? And that's what we're solving for. We need to cross multiply. 1 times X is X, or 1X. 3 times 400 is a little bit bigger number. If you want to use the shortcut, 3 times 4 is 12. And then I add 2 zeros. So we have 1,200. We're not rounding this or anything, so 1,200 feet. So this is my sort of in-between answer. So I'm going to put a dotted box around this. It's not quite done. I wouldn't want to pick that answer on the STAR test if it was an option, because I still need to come over here and plug it into my distance formula. So now, instead of using 400 yards for my distance, I'm going to use 1,200 feet. They're equal. So 400 feet equals my rate, and the rate is 8 feet per second. And since I'm using feet and feet, then I'm good, times the time. And this is just a regular old equation. So we're going to divide both sides by 8. That's going to help us get t by itself. The 8's cancel out over here. We don't have any zeros to cancel out over here, so we're going to leave that. And we're going to get something equals time. Well, let's go over to the side and do some side work. 400 divided by 8. We need to move our decimal up to the quotient. So I'm going to let you go ahead and do this division problem. When you're finished, push play and double check your work. And please pause the video now. Okay, so I got 50 for my time. Now if you got 5, then it's because you forgot to bring down this extra 0 and then put your 0 up here. So make sure that your decimal is in place so that you realize that you've got that spot right there. So 50 equals time. 50 what? Well, seconds, because it was 8 feet per second. So 50 seconds is our time. Again, if you're having trouble with this one, maybe you're having trouble with the conversions or just plugging it into the distance formula, kind of put a star next to this problem, write down what it is that you're struggling with, and when you're finished with the review, you can ask your teacher about it. All right, let's go on to number 4. Number 4 says Ellen was reading her pulse. Her pulse is like you can take your pulse, your heart rate on your wrist, or on your neck. Excuse me. So it's your heart rate. So she was reading her pulse at rest, so without doing any exercise, and found that it was about 83 beats per minute, or it was 83 beats per minute. Which of the following could she use to determine P, her pulse in beats per, and this should say second. Okay, so if yours, I think I corrected these, but if not, if you'll change this to say feet per second. Now, this is not really the way that we have shown you how to do these conversions. This is a way to do conversions, but it isn't what we've practiced mostly. So I just want to show you this so that you're familiar with it and you're able to recognize kind of what this looks like on your test. The first thing I want to do is I want to write down my my beats per minute. Okay, so I want to write down 83 beats per minute. So let's see what we can get rid of here. Here I have 83 beats per minute. Okay, so we're going to leave that one alone. This one also says 83 beats per minute. This one also says 1 minute per 83 beats. Okay, and then this one says 83 beats per minute. So I'm going to get rid of C because I really want it to be beats per minute. I want minutes on bottom. Then I need to figure out how many minutes and how many seconds we have. So we have 1 minute. If you look at your formula chart, we know that 1 minute equals 60 seconds. So I'm going to find something that says 1 minute over 60 seconds, or 1 over 60. And this one says 1 over 60. 1 minute over 60 seconds. This is, we already got rid of it, but it says 60 minutes in 1 second, and that's definitely not true. 1 second does not equal 60 minutes here, so we can get rid of that one. So the only difference in the two that we have left is that this one has seconds on top and this one has minutes on top. Now, I don't want to confuse you, because we know that whenever we're solving a proportion, we have to be consistent. So if I'm going to do minutes over seconds, I have to keep it minutes over seconds for the whole problem. So this only applies to when we're solving a problem this way. Notice that there's not an equal sign here. This is not a proportion. This is a multiplication sign. That's like that dot or an X to multiply. So this is not a proportion. In fact, I'd like for you to write that on your paper. Not a proportion. So we're really good at solving problems using proportions. But I just want you to be able to recognize this type of problem, recognize when you see something like this, even though you're not going to see it that often. So, what I want to be able to do, switch colors here, I really want to be able to cross out my minutes on top and bottom. Let me make that a little darker. Okay. That's what I want to be able to do. Here, both of my minutes are on bottom, and then I have beats and seconds on top. Here, I have minutes on bottom, and that cancels out with the minutes on top. This is just like whenever we have 530 divided by 10. We have a 0 on top and we have a 0 on bottom that we can cancel out. This is the same thing. So this is going to be the answer that I would choose, simply because when I finish, let me get a better color here. When I finish this problem, because I was able to cancel out minutes on bottom and minutes on top, I'm going to be left with beats per second. Okay, so I'm going to cross out why is this the wrong answer. And it's the right answer because I'm left with beats per second. That's why. Now, these two I got rid of. This one I got rid of because it said, okay, 60 minutes equals 1 second. Well, that's not true. So 60 minutes does not equal 1 second. So that one can't be right. This one, 1 second, same thing. 1 second does not equal 60 minutes. It's the same thing, they just flip-flopped it. And this one up here, I'm choosing to not take this answer because I cannot cross out minutes and minutes down here. I can't cancel out the minutes. Because remember, we want to get rid of the minutes. We want to get it into seconds. So, I just want you to look at this for a second. If it's a little bit confusing, put a star next to it, and kind of note which of these answer choices are giving you trouble, so that when you're finished with the review, you can bring it to your teacher and talk about it and make it make a little bit more sense. Again, on this one, this is not a proportion. That's why we wanted the minutes to be on top and bottom. This is pretty much one of the only times we're ever going to want that. Okay, let's look at number 5. Number 5 says, consider the following graph. All right, so we're just looking at it. When it says consider, it means kind of look at it and think about it for a minute. So we're thinking about this graph. What is the slope? What is the y-intercept? And then we need to write an equation in that form. So I want you to think back for just a minute about last week whenever we did that linear relationships project. So we had 8 different problems, and they were half pages, and then you had to read the problem, make a table, and then graph it, and then you had to write an equation at the end. Well, that's all we're doing here. So we're given the graph. If you want to make a table out of this, you could, but I really don't think you're going to need to. Because all we need is to look at this graph, and we can easily find the slope and the y-intercept. So, let's start with the y-intercept. I always think that one's the easiest. I don't know why. But here is our slope, here's our y-intercept. Wherever the line hits that y-axis, and remember, this is the y-axis. So it hits the y-axis at -2. So my y-intercept is -2. Now the slope, remember slope, that's our constant. So constant and slope are the same thing. This is our constant rate of change. The slope is how our line changes. And we figure that out with the formula rise over run. So I want everybody to go ahead and write down this formula, rise over run. So we're just going to pick a point on the graph, and it's usually easiest to start at the y-intercept. And then we're going to figure out another point on the graph that's easy to look at. So I'm going to use this one. So I just want to see how much do I rise and how much do I run to get to this new point. So I'm basically on a trip from here to here. So my rise is 1, 2. So I rise 2, so that's positive 2. If I had had to go down, it would have been negative 2, but we don't want to worry about that because this one's positive. And then I'm going to the right, so positive again, 1, 2, 3, 4, 5. So this is my slope, 2/5. Now we could also change that. You might see that as a decimal. 2/5, that's the same thing as 4/10 or 0.4. Okay? The y-intercept is -2. So remember that when we go to write our equation, we always have to write the equation in this form. I bet you remember it. It always has to be y equals something x something. Y equals mx plus b. Well, here's my plus b. Okay? That's our y-intercept. So instead of it being plus something, it's going to be minus 2, since it's -2. And m is this slope, so 2/5. So all I've done here is I took my slope and plugged it in. And we found that by doing rise over run. That's why it's a fraction, and it's okay. And then we found our y-intercept just by looking at where the graph, the line, hits the y-axis. And then we just plug in those numbers. It's the same thing we did on that project, and you guys were really good at that. The main thing is making sure that you remember that plus b is the y-intercept, and m is your slope. So make sure that we don't get those confused. So y equals 2/5 x minus 2. If you're concerned about slope or y-intercepts or writing equations, then put a star next to this one so that you can ask your teacher about it when you're finished with the review. Number 6. Elijah earns $1,000 each month working a part-time job. He wants to save $2,400 for college over a 1-year period. What percentage of Elijah's total monthly budget should go to his college savings to meet his goal? So this is going to be a multi-step problem. First, we need to identify some things. He earns $1,000 each month. And he wants to save $2,400 over a 1-year period. Well, okay, let's think to ourselves. A 1-year period, but his salary is in months. So, and we usually do monthly budgets. So let's change this into months. Let's just do that really quick. Your formula chart tells you that 1 year is 12 months. Oops. Okay. So we can rewrite that. We can, instead of the word 1 year, we can write in 12 months. He wants to save $2,400 for college over a 12-month period. So let's decide how much he needs to save each month. If he wants to save $2,400 and he has 12 months, let's see how much he needs to save each month. Put a decimal here, put it up in your quotient. I'm going to ask you to do this division, and then you'll push play to double check your work. So please pause the video now. Okay, so I worked this out. I don't want to stop at the $2 per month would not make any sense. We need to know that I'm going to have to save a lot more than that for college if I'm trying to save up this much in 1 year. So $200 per month is what we need. So that's our first part. We're more than halfway done now. The question says, what percent? So what percent of his budget? So let's think back. About a week and a half ago, we were doing percent proportions. Actually, I guess a week and a half ago, we were doing percent proportions. And remember that percent proportions are solved exactly the same way as regular proportions. It just has a special formula. And that special formula is, you already know it, is over of equals percent over 100. Another way to write that is part over total equals percent over 100. And remember that when we're solving a percent proportion, and we know it's a percent proportion because the problem talks about percents, so we need to set it up as line equals line 100, because that 100 is always going to go there. Now I'm going to start with my percent and ask myself if I know the percent, and if I do, I'm going to plug it in. Well, do we know the percent? Nope. It says what percent, so that is what we're looking for. That's X. Next, I need to decide, I need $200 per month, and I make $1,000 per month. I don't need any of this anymore, because that's how much he needs to save over 1 year. All we care about is monthly. So what I could do is say he wants to save $200 per month. That's all that matters now, how much he needs per month. So which one of these is our part and which one is our whole? Well, $200 is the part that I'm going to be saving, so I'm going to put that on top. And then he earns $1,000 each month, and that's his total. So let's go through and make sure this all makes sense before we continue. We have $200 out of $1,000, so this is our part and our total, and we want to know what percent this is. So now that we've set it up, all we have to do is cross multiply. And you guys are really, really good at setting these up and then cross multiplying. So let's do that. This is 1,000x equals 200 times 100. Okay, if you want to take the shortcut, 2 times 1 is 2, and then I have 1, 2, 3, 4 zeros. So that's 20,000. If you want to multiply it out, that's great too. Set it up as 200 times 100, and you will get the same answer. And if you're doing that, go ahead and pause the video, work it out, and make sure that you get the same answer before we move on, so that we know that you're in the right place. Then I need to go and divide both sides by what? What am I dividing by? Whatever's in front of x. So I'm going to divide by 1,000 on both sides. And a lot of times we look at things with zeros and we say, oh, those are easy, it's just a bunch of zeros. But it's so easy to leave off zeros or put in extra zeros or get confused on how many zeros we have. So you've got to be really neat and organized and really make sure you know what you're doing when we have all these zeros. So my 1,000 divided by 1,000 cancels out, and I'm left with just x. Over here, there's some stuff I can cancel out. I can cancel out these zeros, and these zeros, and these zeros. So if you make that a little darker, those, and those. Now I'm left with 20 over 1. Well, 20 divided by 1 is 20, but I'm not finished. I need a label on my answer. The question said what percentage, so my answer is 20%. So that was a really long problem, but we know how to do all of this. All we did was change 1 year into 12 months, we figured out that $2,400 per year divided by 12 gives me $200 per month. And then we set up a percent proportion to find what percent is 200 out of 1,000. All of this is stuff that we know how to do. It just takes a while because there's so many steps. Again, if any part of this is giving you trouble, put a star next to it, write down exactly what it is that's causing you some concern, and we can look at it when you're finished. Okay, so now let's look at number 7. Zoom in here just a little bit. Okay, the table below shows Marcel's budget last month. So we see what she bought, what she paid for, how much she spent on each category. About what percent, I'm going to go ahead and underline this because I know that's going to be important. What percent of Marcel's monthly budget was spent on groceries? Alright, so since this has a percent in it, I know that there's a good chance that I need to use the is over of equals percent over 100 formula. And remember that another word for is part, and another word for of is total. So we are all set. We already know that we're going to be looking for the percent because the question says what percent. And so now we can go ahead and set up a proportion. Line equals line 100. I know that I'm looking for the percent, so I'm going to go ahead and put my X here and get that out of the way. And then I know that I'm looking for the part that was spent on groceries. So groceries was $140. So that's my part. Okay, what percent was spent on groceries? That's part of my budget. It's not my total budget, it's just part of my budget. So I'm going to put 140 on top over here in the is place. And then of is our total budget. And we don't know the total budget. They didn't give us an amount, but I bet we can figure it out pretty easily. If I add up all of these amounts, I will find my total budget. So let's go ahead and do some side work over here. 750, 150, 140. Okay, make sure that we're lining everything up really straight, really neat. 90, so the 9 needs to go under my 4 so that my decimal points, these are all my decimal points, they need to line up. And 70. So let's double check. I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. And we're adding. So bring down that decimal point. I'm going to ask you to go ahead and do your addition and find your total, and then push play again to double check your work. So please pause the video now. Okay, when I added up all of these amounts, I got $1,200. There's nothing after the equal sign, or sorry, there's nothing after the decimal point. So my total budget is $1,200. That's what I will put down here. And now we are all set up. Let's make sure that we have everything in the right place. Percent, which is what we're looking for, over 100. This is the part that we're spending on groceries, and our total. So let's cross multiply. X times 1,200 is, 1,200 X equals, remember proportions always have to have an equal sign in the middle, 140 times 100. So if you want to do the trick, 14 times 1 is 14, and then I need to add 1, 2, 3 zeros. Or, if you prefer to just do it as side work, 140 times 100, you can pause the video and work that out and make sure that you have 14,000. Now the next thing that we need to do is divide both sides by 1,200. Because I want to get x by itself. So I divide by whatever's in front of x. And now I have x. And then over here, I can cross out 1 0, 2 zeros, because they both end in 2 zeros. And so really all I have now is 140 divided by 12. So x equals, and I'm going to go over to the side and do 140 divided by 12. We always want to bring our decimal up to the quotient before we start dividing. 12 goes into 1, not at all, but it goes into 14 one time. 1 times 12 is 12. We subtract and get 2. Let's bring down a 0. 12 goes into 20 one time. 1 times 12 is 20. 1 times 12 is 12. What am I talking about? 1 times 12 is 20. Ha, I hope y'all caught that. Okay, 1 times 12 is 12. I subtract. I'm going to come down here a little bit and get 8. So now we need to add another 0 after the decimal point. That's why it's really important that we already have it there. Bring that down to 80. 12 goes into 80 6 times. And if we don't know that, we can add them up. 6 times 12. Oops. Okay, 72. We subtract and get 8 again, so this is just going to repeat. We're keeping on getting 8, so it'll be 0.66666. So this is about 11.6 repeating percent, or maybe the answers would round up to the nearest whole number, so maybe 12%. Depends on what the question asks you to do. In this case, it didn't tell us to round, so we would just put this, 11.6% with a repeating bar over the 6. If it said to round to the nearest whole percent, we would give 12%. So if you're having trouble with this, either with adding up the budget or with your part over whole equals percent over 100 formula, then put a star next to this and kind of write down what your question is. And then you can ask your teacher about it when you finish your review. So we only have 3 questions left. All right, let's look at number 8. Lexi receives a gift card for $45 to use for blizzards at Dairy Queen. All blizzards cost $2.25. Create a table to represent the relationship between X, the number of blizzards Lexi can buy, and Y, the balance remaining on the gift card. So we're going to go ahead and set up our table. So this is the number of blizzards, and this is our balance. And it says the number of blizzards Lexi can buy, but I think the way that we need to interpret this is the number of blizzards Lexi has bought. Okay? That's what I'm thinking. So based on that, that's how we're going to go ahead and set up this table today. So if Lexi has bought 0 blizzards, how much money does she have on her gift card? What I'd like for you to do is go ahead and fill in what you think the balance would be when she's bought 0 blizzards, and then push play to double check. So pause the video now. Okay, so when I bought 0, or if Lexi had bought 0 blizzards, then that means that her balance is still $45 because she hasn't spent anything. Now, if she buys 2 blizzards, That means that I've paid $45 minus $2.25 minus another $2.25. So now I need to figure out what $2.25 times 2 is, first of all. So what would it cost to buy 2 blizzards? $2.25, and I'm just going to add rather than multiply. So when we add, we do line up our decimal, bring it down to your sum, and we're going to add. So that's 10. 2 plus 2 is 4, plus 1 is 5, and then 4. So $4.50 for 2 blizzards. So that's how much it cost. But that's not how much I have left on my gift card. I need to subtract that now from $45. So let's figure out $45 minus $4.50. It's so important that we line our decimal points up when we're subtracting. That's the biggest thing that people kind of mess up on. So 0 minus 0 is 0. I need to borrow here, so that becomes a 4. This becomes a 10. 10 minus 5 is 5. And then 4 minus 4 is 0. And then I just bring down my 4. So $40.50 left over. All right, good. So now we're going to buy 2 more blizzards. Now we're going to make it 4. So I'm going to subtract $4.50 again. So let's come over here. We have $40.50 on the gift card. And we're going to subtract $4.50. Bring down that decimal point. And I'd like for you to go ahead and subtract to get your answer here. And then I'd like for you to subtract again to figure out what the balance would be after she had bought 6 blizzards. So I'd like for you to pause the video. This might take you a couple of minutes. And then once you've subtracted $4.50, put that here. And then subtract another $4.50 for these 2 and put that here. And then push play to double check your work. So pause the video now, please. Okay, so I subtracted $40.50 minus $4.50, and I got $36. So if I've bought 4 blizzards, I now have $36 on my gift card. And then I buy another 2, so I subtract another $4.50, and I get $31.50. And that would be my balance after buying 6 blizzards. Again, if you're having questions on how to take a word problem like this and turn it into a table, then put a star next to this, and then kind of write down your question so you don't forget, and then you can ask your teacher when you're finished with your review. Number 9. Malik wants to buy a new laptop at Best Buy. A brand new laptop is on sale for 2/3 of the original price with an extra discount of $50. What is the y-intercept? What is the constant rate of change? And write an equation to represent y, the amount that Malik paid for the laptop. So remember, it needs to be in y equals mx plus b form. So we want to kind of divide this up. This is a little bit of a different problem than what we're used to, because the problem's not asking us to look at, well, what's the sale price if the original price is this? And what's the sale price if the original price was this other thing? So even though it's not asking us to do that, we can still set up a table, and we can still start off by doing that. So let's look at this as the original price and then the sale price. We're just going to have a few little entries here. So let's just say, just for the sake of finding our y-intercept and finding out if this is proportional or not, let's just make the original price $0. So I know that would never happen, but let's just say hypothetically, if the original price was $0, then we'd be paying 2/3 of that. 2/3 of 0 is 0. And then an extra discount of $50. So that means I'd actually be paying negative $50. They'd actually be giving me $50 to take this laptop. So I know that would never happen. But let's just say. All right, let's say now that the laptop was, let's say $75 normally. Okay, well 2/3 of 75 is 50, and an extra discount of $50, so $50 minus $50 is 0, so I'd actually be getting it for free at that point. Again, I know this would never happen. This is like make-believe land. Okay, now let's say that the laptop was normally $150. 2/3 of that would be 100, with an extra discount of $50 would bring the price down to $50. And then let's do one more, $225. We're just going up by 75 each time. And I picked 75 just because that's easy to divide by 3. That's all. Okay, so $225, 2/3 of that is $150. And then an extra $50 off, the laptop would be $100. So notice that we can actually take this word problem, even though it didn't ask us to set up a table, we can set up a table and use our own numbers and kind of get an idea of what our equation might look like. So the y-intercept is whatever y is when x is 0. So here x is 0. That's why we took it all the way back to 0. So my y-intercept, it's not actually going to be a plus b, it's going to be a minus b. So minus $50, or negative 50, is my y-intercept. So I already know, when I'm looking down here to write my equation, y equals something x something, I already know that this part right here, the y-intercept, is going to be minus 50. So I'm halfway done now with this problem. The constant rate of change is 2/3. Because it's 2/3 of the original price, or 2/3 times x, the original price. This could also say 0.67 or 0.66 repeating. Okay. So 2/3 of x, or 2/3 times the original price, minus $50 is what we're going to pay for the laptop. So please put a star next to this, and specifically which part is giving you the most trouble, so that you can ask your teacher about this when you finish the review if you have any questions. Sorry about that, that was my phone. All right, we got rid of that. All right, so let's flip over to the very last one, number 10. Carmen and Jose are newlyweds looking to cut down on their spending. Their monthly budget appears below. Which of the following is the best way for Carmen and Jose to save money? And then explain each incorrect answer. So explain why each one is wrong, except for the right one, which is right. Okay. So what I want you to think about first, before you ever even look at the answer choices, is, first of all, what the question is asking. The question says they're looking to cut down on their spending. It doesn't say that they're looking to earn more money. So we're only looking at our expenses here. Only looking at what we're spending. Income doesn't matter. So we always want to be aware of exactly what the question is, so that all we're focusing on is answering that question. Now, let's look and see which of these are fixed expenses and which ones are variable expenses. So remember, back when we did a lot of work with budgets, we talked about fixed and variable expenses. And fixed expenses are the ones that stay exactly the same every month, like my mortgage payment and my car payment and, what else? My insurance. All of those stay the same every month. But then there's other things like shoes and school supplies and spending money and things like that that will change each month. So we're going to go through and decide whether each one of these is fixed. That means it stays exactly the same every month. And which ones are variable. That means that they can kind of change, like some months I'll spend more, some months I'll spend less. So I'd like for you to pause the video and go ahead and just put an F or a V next to each one of these expenses and then push play to check your answer. So please pause the video now. Okay, so welcome back. You should have an F or a V next to each of your expenses. So let's go through them quickly. The telephone and internet is pretty much going to be a fixed expense. It's going to stay the same each month. So my AT&T bill is the same each month regardless of how much internet I use. Clothing is variable. So this month I haven't bought any clothes, but back in August before school started I bought a lot of stuff. My rent stays the same every month. It's going to be, $550 a month or $1,000 a month, and that doesn't change unless I move. My utilities will vary. For example, during the winter, my AC bill, my electric bill will probably be lower because I'm not going to be spending as much on air conditioning. Car insurance is fixed. It stays the same each month. And entertainment is variable because, if I'm really struggling to make it, one place that I can cut is my entertainment budget. So some months I spend a lot on entertainment, some months I don't. So let's look at each of these answer choices. All right, what's the best way for them to save money? A, they can best save money by spending less on rent and utilities. Okay, maybe. Let's look. Both are fixed expenses. All right, well, let's check that. Rent is fixed, and utilities is not fixed. That's variable. Okay, so already we know it's wrong. Okay, utilities is not fixed. Okay, but also, do they change based on the couple's habits? Well, rent does not change based on their habits. Okay, their rent's going to be the same every month no matter what they do, unless they move, and that's not a habit. So, all right, I'd like for you to look at B. Go ahead and read B. Decide if you think this is the right answer, and if not, I want you to write why you think it's wrong in the blank. And then when you're done, you can push play and double check your answer with me. So please pause the video now. Okay, welcome back. All right, B says they can best save money by spending less on rent and utilities, so same things, rent and utilities, and it says that they're both variable expenses that don't change. All right, well, there's two things wrong with this. One is that rent is not variable. And then secondly, we know that the word variable expenses means that they do change. Okay, so it's the wrong definition of variable expense. Okay, a variable expense can vary. That means it changes. So the the answer choice gave us the wrong definition. Okay, please take a look at C and do the same thing. I'd like for you to pause the video, analyze this one, write down why it's wrong, or decide that it's right, and then push play to check your answer. So pause the video now. Okay, let's look at C. They can best save money, sorry, this should say save money, by spending less on clothing and entertainment. Both are variable expenses, so let's stop. Don't keep reading yet. Clothing and entertainment. Variable, variable. Yep, okay, so they're both variable expenses. And do they change based on their habits? Yes, they do. Okay. Clothing changes based on how much I go shopping. Entertainment changes based on how much I go to the movies. So maybe that one. Let's go to D and do the same thing. So pause the video, write down why you think it's wrong or decide that you think it's better than C, and then push play so that you can check your answer with me. So pause the video now. Alrighty, so it says they can best save money by spending less on clothing and entertainment, so the same ones. Both are fixed expenses that don't change. Well, that's not true. They're not fixed, they're variable. Both are variable. So we know that this, C, would be our best answer here. If this one's given you some trouble, one thing you can do is look back at your notes on fixed and variable expenses, because I know it's been kind of a long time since we've reviewed that. And then secondly, if you would like to put a star next to this, you can talk to your teacher about it and get some help from your teacher. Remember that this video is available online, so you can go to the website when you get home and you can rewatch whatever parts you need to, or if you get an early dismissal today, you can finish watching it at home. You can even download this review and look at it or print it off while you're watching the video at home. So go home, study whatever you can, practice these questions, rework them several times, and I think you'll do really, really well tomorrow. Thank you, and I hope you have a wonderful rest of the day.